In this video, I will be talking about limits at infinity. Before we move on with the examples, we need to know a few theorems. The limit of x to the power of any number as x approaches infinity is always infinity. The limit of x to the power of negative n, which can also be written as the limit of 1 over x to the power of any number, when x approaches infinity, is always equal to 0. The limit of x to the power of any number as x approaches negative infinity is infinity if n or any number is even, and is negative infinity if n or any number is odd. The limit of x to the power of negative n is also equal to the limit of 1 over x to the power of n as x approaches negative infinity is always equal to 0. These theorems will make more sense as we do a few example questions. Our first example is to evaluate the limit of x over x plus 9 as x approaches infinity. Our first step is to divide the top and bottom by the highest power. In this case, the highest power is x to the power of 1. We can write that as x to the power of negative 1 multiplied by x, and x to the power of negative 1 multiplied by x plus 9. X to the power of negative 1 multiplied by x just becomes 1, and x to the power of negative 1 multiplied by x plus 9 becomes 1 plus 9 over x. Using the quotient rule, we can then separate the numerator from the denominator and write it as the limit of 1 when x approaches infinity divided by the limit of 1 plus 9 over x as x approaches infinity. Using the sum law on the denominator can split the limit up. So it would be limit of 1 as x approaches infinity plus the limit of 9 over x as x approaches infinity. The limit of a constant is the constant. So the limit of 1 as x approaches infinity is 1. And same on the bottom here too. But the limit of 9 over x is equal to 0, because as we remember, we can see here that as the limit of 1 over x as x approaches infinity is always equal to 0. The limit of x over x plus 9 as x approaches infinity is 1. Our next example is to evaluate the limit of 2x to the power of 5 plus 3x to the power of 4 minus 31x divided by 8x to the power of 4 minus 31x squared plus 12 as x approaches negative infinity. Our first step is to divide both the top and bottom by the highest power in the denominator, which is x to the power of 4. We can do this by multiplying x to the power of negative 4 to both the numerator and the denominator. This gives us the limit of 2x plus 3 minus 31 over x cubed all over 8 minus 31 over x squared plus 12 over x to the power of 4 as x approaches negative infinity. According to this theorem here, the limit of x to the power of 1 as x approaches negative infinity is negative infinity. So down here, the limit of 2x would be negative infinity. the limit of a constant always stays the constant. So this stays as plus 3. And this fraction is over x, so it stays at 0. Down here, 8 stays as 8 because the limit of a constant stays the same number. This value is over x, so it stays at 0. And this value is also over x, so the limit of it is also 0. This gives us negative infinity over 8. The negative infinity plus 3 here does not make much of a difference because negative infinity is such a small number. We can also apply that same rule to the divided by 8. This just becomes negative infinity. Therefore, the limit of 2x to the power of 5 plus 3x to the power of 4 minus 31x over 8x to the power of 4 minus 31x squared plus 12 as x approaches negative infinity is negative infinity. The next step is to multiply the numerator and denominator, divide the numerator and denominator by the highest power of x in the denominator. In this case, it's x to the 4, but because it's in a square root, it would actually be x to the 4 over 2, equaling x to the power of 2. But since this is also in the denominator, we would make this x to the power of negative 2. So to divide x to the power of negative 2, we can multiply x to the power of 2 to both the top and the bottom. That would give us the limit of 8 plus 7 over x to the power of 5 over 3 all over the square root of 16 plus 6 over x to the power of 4 as x approaches negative infinity. The limit of 8 stays as 8. Because this value is over x, the limit of this is 0. Here, the constant stays the same. And since this value is over x, the limit also becomes 0. In this case, we get 8 plus 0 over the square root of 16 plus 0, which is also equal to 8 over 4. And therefore, the limit of 8x squared plus 7x to the power of 1 over 3 divided by the square root of 16x to the power of 4 plus 6 as x approaches negative infinity is 2. And that summarizes out the limits at infinity.